I hear this in my clinic almost every single week. A patient sits right where you are. Maybe they are 65, 75, or 85, and they look at me with real fear in their eyes. They say, "Doc, I walked into the kitchen yesterday and completely forgot why I went in there." Or, "I couldn't remember my neighbor's name for 5 minutes. Am I getting Alzheimer's?" If you are over the age of 60, I know this is likely one of your biggest health concerns. We value our independence, and the thought of losing our memories, losing the very essence of who we are, is terrifying. But here's the clinical truth. Forgetting where you put your keys or struggling to recall a word is usually not a sign of dementia. Today, we are going to dive deep into the science of the aging brain. I'm going to show you exactly how to tell the difference between normal age-related memory loss and the actual red flags of cognitive decline. More importantly, I'm going to share groundbreaking clinical research that proves cognitive decline is not always an inevitable part of aging. You have much more control over your brain health than you might think. Welcome back to Health and Well-Being. I'm so glad you're here. Let's start with what happens to a normal, healthy brain as we cross our 60th birthday. By the time we reach this milestone, the brain physically changes. The cortex thins out, and the hippocampus, the region of the brain responsible for forming new memories, actually shrinks slightly. Blood flow to the brain also decreases. Because of these normal structural changes, your processing speed slows down. It takes longer to recall a name or learn a new piece of technology. That is a physiological fact of aging, not a disease. So, how do we differentiate between a normal, aging hippocampus and the onset of a neurodegenerative disease like Alzheimer's? In medical practice, we look for 4 distinct differences. Number 1, the type of forgetting. Normal aging is forgetting the name of an acquaintance you haven't seen in a year, but remembering it later that night. A red flag for dementia is forgetting the name of a close family member or getting lost driving back to a house you've lived in for 20 years. It is a forgetting of deeply ingrained information. Number 2, misplacing items. We all lose our reading glasses or the TV remote. That's normal. A patient with early-stage dementia won't just lose their glasses. They might find them in a refrigerator. Or, more concerningly, they might hold the glasses in their hand and no longer understand what they are used for. Number 3, the loss of executive function. This is a critical clinical marker. Executive function is your ability to plan, sequence, and solve problems. If balancing your checkbook, paying regular bills, or following a family recipe you made 100 times suddenly becomes a confusing, impossible task, that is a warning sign. Number 4, changes in personality or social withdrawal. Very often, before severe memory loss occurs, a patient will experience shifts in mood. They may become easily agitated, suspicious of loved ones, or completely withdraw from social activities, church groups, or hobbies they used to love. Often, this withdrawal happens because following a fast-paced conversation has become too overwhelming for their brain to process. Now, let's talk about why abnormal cognitive decline happens. For a long time, we thought it was just bad luck or genetics. But clinical research over the last 2 decades has completely shifted how we view Alzheimer's disease. In fact, a pioneering neuropathologist at Brown University, Dr. Suzanne de la Monte, made a massive breakthrough. Her research team coined a new term for Alzheimer's. They called it type 3 diabetes. Why? Because there's a profound science-backed link between insulin resistance and brain starvation. When you consume a diet high in processed foods, refined sugars, and simple carbohydrates, which is unfortunately the standard American diet, your body constantly pumps out insulin to manage the blood sugar spikes. Over the decades, your body cells become resistant to that insulin. You probably know this as a pathway to type 2 diabetes. But here's what most people don't know. Your brain cells also need insulin to absorb glucose for energy. Dr. de la Monte's research showed that the brain itself can develop insulin resistance. If your brain becomes insulin resistant, the neurons literally cannot get the fuel they need. They starve, they stop communicating, and eventually they die. This means that managing your metabolic health, keeping your blood sugar stable, is quite literally one of the most powerful things you can do to protect your memories. This brings us to our first major strategy for protecting your brain: nutrition. Specifically, something called the MIND diet. In 2015, Dr. Martha Claire Morris, a nutritional epidemiologist at Rush University Medical Center, developed the MIND diet. It stands for Mediterranean-Intervention for Neurodegenerative Delay. Her research team tracked nearly 1,000 older adults for up to a decade. The results were staggering. They found that older adults who strictly follow the MIND diet reduced their risk of developing Alzheimer's disease by 53%. Even those who only followed it moderately still saw a 35% reduction in risk. So, what is the MIND diet? It focuses heavily on foods that reduce oxidative stress and inflammation in the brain. Asterisk green leafy vegetables, spinach, kale, and collard greens. Dr. Morris found that people who ate leafy greens just 6 times a week had brains that functioned as if they were 11 years younger. Asterisk berries, specifically blueberries and strawberries, which are packed with neuroprotective antioxidants. Asterisk healthy fats and proteins. Extra virgin olive oil, nuts, beans, poultry, and wild-caught fish rich in omega-3 fatty acids, which help maintain the integrity of your brain cells. Just as importantly, the MIND diet restricts the foods that drive that type 3 diabetes effect: butter, cheese, red meat, pastries, and fried foods. Our second science-backed strategy is movement. I know you've heard that exercise is good for your heart, but I want to tell you what it does to your brain. For a long time, doctors believed that once brain cells died, they were gone forever. We now know that is false. Through a process called neurogenesis, your brain can grow new cells, specifically in the hippocampus, that memory center we talked about earlier. In 2011, a landmark clinical study published by Dr. Kirk Erickson completely changed the game. He took a group of older adults and had them do moderate aerobic exercise, like brisk walking for 40 minutes, 3 times a week. After 1 year, they scanned their brains. The control group, who only did light stretching, saw their hippocampus shrink by over 1%, which is the normal rate of aging. But the group that did aerobic exercise, their hippocampus actually grew in volume by 2%. They literally reversed brain aging. How? Aerobic exercise triggers the release of a protein called BDNF, brain-derived neurotrophic factor. I like to explain BDNF to my patients as miracle grow for the brain. It acts as fertilizer, encouraging new neurons to grow and survive. You don't need to run a marathon. A brisk walk to get your heart rate up is enough to trigger this response. As a doctor, my goal is not just to add years to your life, but life to your years. If you or a loved one are experiencing those red flags we discussed, getting lost in familiar places, severe confusion with daily tasks, or significant personality changes, please do not wait. Schedule an appointment with your physician or a neurologist. Early intervention, cognitive testing, and ruling out reversible causes like vitamin B12 deficiency or thyroid issues are crucial steps. But if you are just occasionally forgetting a name or misplacing your keys, take a deep breath. It is likely just a normal part of your brain's aging journey. Focus on what you can control. Keep your blood sugar stable, eat your leafy greens and berries, and get out for that brisk walk to boost your BDNF. Thank you for joining me today on health and well-being. If you found this clinical breakdown helpful, please hit the like button and subscribe to the channel so you don't miss our next deep dive into the science of healthy aging. Until next time, stay active, eat well, and take care of your health.